This is the last type of KSP problem, predicting the formation of precipitates. We know that if QSP is greater than KSP, a precipitate is going to form. We know if QSP is less than KSP, no precipitate forms. So here's our question. Will magnesium carbonate precipitate from hard water containing 0.01 molar magnesium 2 plus and 0.001 molar carbonate ion given the KSP of magnesium carbonate is 2 times 10 to the negative 8th. So we can see here that our value for Q would be calculated from the magnesium concentration and the carbonate concentration. And so I simply plugged in the values, and we have that Q is 1 times 10 to the negative 5th. So we're going to compare Q versus Kp. So when we compare these, we can see that Q is greater than KSP, which means that a precipitate forms. Our next problem is more challenging. Will precipitate form if 200 mL of 0.01 molar magnesium chloride is combined with 300 mL of 0.002 molar sodium carbonate, and we're given the KSP of magnesium carbonate as 2 times 10 to the negative 8th. So I have a little drawing here that shows that we have a beaker with magnesium chloride, and I've converted the mLs to liters. So we have 0.20 liters, and we have 0.30 liters of the sodium carbonate. We're going to combine them to make a 0.5 liter mixture. So what we need to do is to find the molarity of the magnesium 2 plus and the molarity of the carbonate ion, and then put that into the expression for QSP. So then we're going to be using QSP is equal to the magnesium concentration times the carbonate concentration. So in order to do this, we're going to have to find the moles of magnesium 2 plus and the moles of the carbonate. So let's find the moles of magnesium 2 plus first. Remember that molarity times liters is equal to moles. So I have 0.01 molar times 0.2, and I'm leading off the trailing zeros just to keep things a little tidier. And that gives us 0.002, sorry about that, moles of the Mg2 plus. And now we're going to do the same thing for the carbonate. So in this case we have 0.30 liters, and we're going to multiply that by 0.002 molar, and that's going to be equal to 0.0006 moles of the carbonate ion. Now we have to figure out the concentration in 500 mLs for each of them. So we have 0.002 moles over 0.50 liters, and that is 0.004 molar for the magnesium ion. And then for the carbonate ion, we have 0.0006 moles over 0.50 liters, and that is equal to 0.0012 molar of the carbonate ion. And last step, we put that into our expression for QSP. So QSP is equal to 0.004, pick that up from there, times 0.0012, and we do the math, and that is 4.8 times 10 to the negative 6th. This is our Q. We have to compare it to our KSP value, which was 2 times 10 to the negative 8th. So there's our KSP. And if we look, the Q is definitely much bigger. So a precipitate forms. Because Q is greater than KSP. Now remember, on the AP exam they'll be fine with you using BC.